Okay, on to the multiple choice. Here we go. Simplify each expression. Hopefully there'll be a lot of these. They're just really straightforward. You've got like terms. So what is 1 apple minus 4 apple? That's minus 3 apples right there. This is distribution twice and then gathering like terms. So when you bring that 2x in, you get 2x plus then 16x squared. Just make sure that when you see an x in two places and you're multiplying, you are watchful for that. Negative 2 times a positive 3x is a minus 6x. Negative 2 times a positive 4 is a minus 8. We gather up like terms. That's just by itself 16x squared. Then I've got x terms, a minus 6 and plus 2. That's a minus 4x, and then minus 8. And I look down here, and they've tried to mess with us a little bit. That's not standard order. Usually this goes first. They're just checking to see if we can move things around. We're not afraid of that. Onto this. This is a simpler version of the above problem. We just have to distribute into that parentheses. Negative 2 times a positive 9 is negative 18. X times x is x squared. Negative times a negative is positive 6x. You will do okay if you are just really clear on those simple rules of math. Which one of these is it? It's right there, okay? Know these fundamental skills. One more practice with distribution, negative 2n. Negative times a negative is a positive 16. Just the number 16, there's no n in there, so it's just a number. Negative 5 times that negative 3n is plus 15n. And then minus 5 times a minus 3 is plus 15. All right, so there's no n squareds in there. There are no n's times n's, but 15 and 16 is 31. And negative 2 from positive 15 is 13n. Where is that? Oh, it's right there, okay? On to this one. All right, so this is telling us to take a square root. That is a helpful hint, but notice that variable is only there one place. There's not two of them. If there were two, like on the next page, we'd have to factor. In this case, we just solve it by peeling away the layers. This is the outer layer, then it's the number, and then it's the exponent, just like our nesting dolls from Russia, all right? So I'm gonna write it over here so I have a little bit more room. And I'm gonna have 6v squared plus 7 equals 271. Take away 7 from both sides. Then I've got 6v squared equals 264. Then I'm going to divide by 6 and divide by 6. 6 goes into 26 4 times with 2 left over, and it's 24 again, so that's v squared equals 44. If I do my factor tree, I get, when I square root that, right, I'm looking for an exact answer. I got to square root that. I get 2 and 22, 2 and 11, tiny little hockey stick with these two going out to the prom, that one left behind. So I've got 2 root 11 as my answer and negative 2 root 11. You will be prompted because the options have 2, but if you ever have one that's not multiple choice, always remember both versions of that, okay? So then on to this page. Similar, only different. In this case, we have a little fraction action. If I take and add 6 to both sides, I'll get 64n squared equals 25. I then divide by 64 on both sides. Again, that variable is only there once, so n squared equals 25 over 64. You shouldn't be afraid of that, because when we take the square root of both sides, we take the square root of the top, that's 5. We take the square root of the bottom, that's 8, and we slap a plus and a minus on it, and there we go, right there, okay? This one is solved by factoring. When they say that, solve by factoring, they're giving you a massive hint that we're looking for things that multiply that will make 0. Once we have that, we just ask, hey, when is this 0? P is 0 when P is 0, so one of my answers is 0. And when is this equal to 0? When P is 0, 0 plus 1 does not give me 0 in that parentheses. I need it to be a negative 1. So negative 1, comma, 0. Usually you put them smallest to biggest. There it is, negative 1 and 0. Same thing here, slightly different. Each of these in turn is 0. That's when k is negative 1 plus 1 gives me 0. And now I have to write a little equation, and I just write 3k plus 2 equals 0. No big deal. Subtract 2, and I get 3k equals negative 2. Divide both sides by 3, and there's my other answer, negative 2/3. So my answers are -1 and negative 2/3, okay? This one now, we actually have to do the factoring. There might be more than just one of these on the test where we have to make those parentheses and we have to figure out, oh yeah, what makes v squared? V times v. What multiplies to make a positive 12 but adds up to make a negative 7? Well, it's only 1 and 12, 2 and 6, and 3 and 4, and I'm adding those up to get 7. So it's -3 and -4. You can always check your work by foiling. And the cool thing is that when you say, hey, when is that equal to 0? You're going to get a +3 and then a +4, and that's it out here. Don't fall for this. This is the rookie mistake where you see the -3 and -4 and think that's the right answer. It's all about when is this 0, okay? A very important skill, very important thing to keep in mind. Okay, now this one's kind of nasty. Sorry about this. Won't do it to you probably on the test. This is multiplying. That's the rule, multiplying rule, so that's 8. And then it's another multiplying rule again. So 8 times 4 is x to the 32. Y to the 4th times 8 is y to the 32 also. Over here, this whole thing is to the 0. That whole thing just becomes 1 and disappears. This part only becomes 1, not the whole thing. If they wanted the whole thing, they used parentheses like they did up there, but they didn't. So just this y is left behind. Y times y is y squared, x to the 4th. Now I use my subtraction rule with the x's, so it's x to the 28th, and when I take away 2 from 30, that's y to the 30th. That is that one, okay? Be careful, there might be a none of these coming up. All right, so now onto this one. Scientific notation. The trick is that this comes in as an exponent, okay, and then we multiply. There's a little invisible 1, so it's 9.3 to the 6th power times 10 to the -30th power. When you do this on your calculator, you'll see that it's going to be about 6.47, and then if you do the math, you're going to have that times 10 to the 5th if you convert this number into scientific notation, and then times 10 to the -30. So these, when you multiply them and they're the same base, we add those exponents, and there we have it, 6.47 times 10 to the -25th. That's that one right there, okay? Your calculator can help confirm that, but you're going to want to show some steps. Factor each of these completely. All right, so we just need to say, well, what multiplies to make this? I'm going to do 2x plus 5 and 2x minus 5. And this one, oh, that is, oh, both of these are not 1. I'm sorry, skip these. That's us, that's in a few days. We're getting ahead of ourselves, just a few days. This one, a little bit more normal in the sense that 7 1/2 is 14, that's 15 halves. Then that's times 10 sevenths, and that's times 4/1. Now we can cancel a 2 and get a 1 and a 5, and that's all we can do. So that's going to be 4 times 15 is 60. 60 times 5 is 300, and those are all 1s and a 7. 300 over 7. Do I see that? Yes, I do, right there. Okay. This one is ugly, but we break it down. This one becomes 15, 16, 17 over 5. Try to show your steps. Plus 1, let's deal with that later. Plus, well, this is 14, 18 over 7. Then times 9 over 10. See how that works? We flip this fraction. When we're dividing by 10 over 9, we flip it and make it multiply by 9 over 10. Then that is one thing. Okay, so let's see. So that's going to cancel an 18 and a 10 and give me a 5 and a 9. And then that's going to be 9 times 9 is 81 over 35. So let's make this all 35 over 35. And let's multiply top and bottom by 7. and I'll get 70 plus 49, 119, and 35. And now let's see, 81 and 119, a very convenient 235. 235 over 35. So I can take out a 5. I divide by 5, and I will get 20. That's 4 and 7. 47 over 7. Okay, you can do that on your calculator, but you'll simplify that down. I'm watching the time here. I'm already over 10 minutes. And then the last page is simplifying radicals. Hopefully this will go quickly. 448. You're going to go 2 and 2, 2, 4, and 2 and 1, 1, 2, and 2 and 56, and 2 and 28, and oh my goodness, 2 and 14, and 2 and 7. 2 and 7. So I've got one pair, another pair, and a final pair of 2s, and a lonely 7. That is 8 radical 7, because it's 2 times 2 times 2, and then times the 7 staying behind in the radical. This one, similar, only different. Keep that 3. Don't forget about the 3. 640 then, when we square root that, is going to be, again, 2 and 320, and 2 and 160, and 2 and 80, and 2 and 40, and 2 and 20. Wow, 2 and 10, this is long. 2 and 5, and we're looking for pairs. There's 1 pair, 2 pair, 3 pair. These guys have no dates for the big semiformal. It's 8 times 3 is 24. Left behind is 10. Then what's happening to that variable? P squared, square rooted. 1p comes out. I'll sneak it in right there. There it is, 24p. Okay, know these skills. These are important. Factor out only a -4. You can take a -4 out from each of these, and then the trick is to check your answer. If I multiply that back in, do I get the same thing? Yes, I do. That'll help you avoid making that +1 error. So where is that down here? Right there, okay? What about this one in the home stretch? I've got an even number, but not one that I can take 4 out of. So I can only take out a 2, and then I can take out 5 m's before they're all gone from somewhere. So if I take out a 2m to the 5th, divide by 2, and I get 5. Take out 5 m's, and there's none left. Divide by 2, and I get 4. Take out 5, and I have 1 m left. Where is that one? Right there. Whoa, that is not right there. Is it there? No. Oh, sneaky, sneaky devils. That is none of these. Last one, same thinking. M's everywhere. There are no n's. The most I can take out is 2 m's right there, so that's on the outside. And left behind when I take out 2 is 2 more, and when I say take out, we're of course dividing. Plus when I take out 2 m's out of 3, there's 1 left with that n. When I take out, there's a 1. Again, we're thinking of dividing. You want to multiply in times 1 and get what you started. Multiply in, check. There's your answer. Where is it? I think it's right there. Okay, 13 minutes. Wow, we're done. Good luck, everybody.